Okay, so these are some notes on ellipses, and the third of our conic sections is the ellipse. So we can describe our ellipse in two ways, just like we did all the other ones. As far as a slice of a cone, when you slice the cone, unlike a circle which slices flat, the ellipse slices at an angle, and technically a circle is an ellipse. It's like a square is a rectangle. But if we slice anything that would hack off the whole top of the cone, then the piece that's left would be an ellipse shape. So a circle is a specified ellipse. As far as the locus of points or the set of all points, it's the set of points in a plane such that the sum of the distances from any point on the curve to the foci is constant. The singular is focus, but we don't say focuses, we say foci. So an ellipse is going to have two focus points, or two foci, okay? So with an ellipse, it's just a circle. If we started with a circle, and we took this radius, and we divided it through to the other side, then I would have my x minus h squared would be over y squared, or r squared, sorry. My y minus k squared would be over r squared, and then I'd have an equal 1 instead. So what makes an ellipse to be this oval shape is when this radius underneath the x squared is a different radius than this radius underneath the y squared, okay? So instead of calling it like R1 and R2 for two different radii, we call them A and B, where A is the amount under the x, or the horizontal stretch, or horizontal radius, and B is the number underneath the y, or the vertical radius. So depending which is bigger, if the number that's underneath the x is bigger, then you're going to have a bigger x radius, and then your ellipse is going to be a horizontal ellipse or a left-right ellipse. Whereas if the number underneath the y squared is bigger, then you're going to have a bigger vertical radius, and that's going to be a vertical ellipse. We talk about these like a radius, but they're not really a radius. What we usually label are called the major and the minor axes. So the big direction, if we think of it like a diameter, is what we call the major axis. Sorry, that would be the big direction. Whereas the short direction's diameter, or double the short radius, we call the minor axis. So if it's a left-right, the minor axis will go up and down. And if it's an up-down, the minor axis is going to go horizontally. And then your major axis would be double the y radius, and that's going to be vertical. Okay. So if we turn the page, there's the example that we want to graph. We can tell that this is an ellipse because it has an x squared and a y squared. So a parabola, either the x would be squared or the y would be squared, but not both. In a circle, these two numbers under here would be the same. So this is an ellipse because we've got the x squared plus y squared, but we're divided by different numbers. So the first thing we're going to do is figure out where's the center, and we do that just like we would for a circle. The number inside with the x is going to move us left and right. It's always going to do the opposite of what it says. So I'm going to start out and I'm going to move 2 points to the left. The number underneath the y, or sorry, the number with the y in the parentheses is your y mover, and that's in parentheses, so you do the opposite of what it says. So I'm going to move up 1, and that's where the center of my ellipse is, so I plot it. So if you look down at the bottom, it's the same one we just drew, with all the center listed, all the vertices listed. The direction we say is vertical because it's longer up and down. So we could have told that by looking at the number that 25 was bigger. Then we need the length of the major axis. So the major axis would be going up and down, and it's the big diameter. So we went 5 up and 5 down, so the major axis was 10. And then the minor axis just goes the short way. And we went 3 left and 3 right, so our minor axis would be 6, because it's going to be like the diameter. To do the domain and range, do it just like a circle. Our leftmost point was at -5 and our rightmost point was at 1. And then they both get brackets because they're solid points. For the range, our lowest point was at -4 and our highest point was at 6. So they both get brackets because you can equal both of them. And those are the points on the ellipse. We didn't really talk at all about the foci. If I were to put, let me clear this out. If I were to put my foci in here, they would be somewhere on this major axis. I'm not going to tell you exactly where they are. I could find it out. We use Pythagorean theorem to figure out where these are, and there's different rules, different versions of the theorem we use for all the different conics. But this distance plus this distance remains constant, so that also means some unique things happen with waves. Like if you were to have an ellipse-shaped machine, like MRI machines are often elliptical shape, and they emit the waves, the magnetic beam from one, it's going to bounce off the side, and no matter which direction I emit from, the curve is going to bounce them all back to the other focus. So if you emit from one focus, it'll bounce off and go to the other focus. The other place, has anybody done the whispering room at the Capitol? You know what that is? It's a room in where, like, if you stand right here and you whisper, you can hear the person over there, but if you were to stand right here, you wouldn't be able to hear them. And it's because all the sound waves that bounce off get filtered back through the same point. So they say that that's one of the ways they designed so that you could snoop and listen to people on the other side of the room. So this is from the homework sheet on ellipses, and the example that's on here is the same example that we just did, so we're not going to do that example again. Let's go down and look at the ones on the bottom and try some of those. Sorry, my copy up here does not look quite as pretty. So this one started out and it was x minus 3, the quantity squared, and then this one was a y squared. So if I'm trying to figure out where the center is, the value with the x, I do the opposite of what it says, so I'm going to move 3 to the right. The value with the y, if I were going to add or subtract something to the y, it would have to be a 0 because I don't move at all. So my center for this ellipse is at 3, 0. So that's the first point that I'm going to plot. Then I'm going to decide where I stretched. The number underneath the x is like the x radius squared. So my x radius would be a 2. And from my center, I'd count 2 left and 2 right, and I'd plot those 2 points. Those 2 points are called vertices. So I would normally have a list where you would write down what they were. So that's 1, 0, and 5, 0 are 2 of the vertexes, or vertices. The number underneath the y is our y radius, and that's squared. So our y radius is like a 3. So I'm going to go up 3 and down 3, and I'm going to plot those 2 points. They're also called vertices. So that was at 3, 3, and at 3, negative 3. And then I'm just going to connect them to make a nice ellipse. I need to answer what is the major axis. So the major axis is the long diameter, which would be doubling 3, which is 6. And the minor axis is my short diameter, which would be doubling 2. So that's 4. The minor axis would be right through the middle there. I could say that this is also up-down if I did the direction, because the big direction is the up-down. That's where the major axis was. And then I just need my domain and range. So my domain goes from my left point to my right point. So that went from 1 to 5. They both got brackets because I could equal them. And my range went from my low point at negative 3 to my high point at 3. And they both got brackets because I could equal them.